Good morning, students. On last time, we were discussing about inverse Laplace transform. We will solve some more questions on inverse Laplace transform. When there are complex roots. Suppose x of s is in this form: a1 divided by s minus alpha minus j beta plus a2 divided by s minus alpha plus j beta. Means roots are in complex form. If x of s is given by 2s plus 3 divided by s square plus s plus 1, and x of t means signal in time domain is right-handed signal, then obtain the value of x of t, or obtain inverse Laplace transform of x of s. First, this is quadratic equation. Find out the roots of this quadratic equation by using this formula. We find out the roots of s square plus s plus 1, and the roots of this equation is r. P1 is equal to half plus j under root 3 divided by 2, and P2 is equal to minus half minus j under root 3 by 2 using this equation, this formula. Here both are complex conjugate of each other. Then write x of s in partial fraction form, a1 by in this form, and here substitute the value of p1. Value of p1 is this, and value of p2 is this, and substitute the value of p1 and p2. Then calculate the value of a1. A1 is calculated by s minus p1 multiplied by x of s, and this value is calculated when s is equal to p1. Then this term is cancelled by this term, and if we put s is equal to minus half plus j under root 3 by 2 in this equation, we get the value of a1. Similarly, a2 is calculated by z minus b2 multiplied by x of s, where s is equal to p2. And if we substitute the value of s in this equation, we get the value of a2, and then write x of s is written as this. This is the value of a1, a2, and s minus p1 and s minus p2. So x of s is written like this. And if we rearrange this equation, rearranging means simply separate the real part and imaginary part. First, we separate this. This is the real part, and this is the imaginary part of x of s. And simplify this equation taking LCM, and then simplify this equation. Here we take the LCM. Here we take LCM and simplify this equation, we get x of s, expression for x of s, which is like this. And this is cancelled by this. So we can write x of s is equal to 2 divided by s plus half whole square of s plus half plus 3 by 4. Similarly, this term is also written as 2s plus 1 divided by s plus half, whole square of s plus half plus 3 by 4. Then take the inverse Laplace transform of this. If roots are complex, first we calculate the roots of quadratic equation, then write that equation in partial fraction form, and then calculate the coefficient a1 and a2. Simplify or separate these two terms, separate the expression in real part and imaginary part, and then simplify. You get the expression for x of s, and this is the expression for x of s. Then take inverse Laplace transform, and this is the for this term we use the standard Laplace transform here. Laplace transform of exponential minus at sine omega t. Laplace transform of exponential minus at sine omega t is given by omega divided by s plus a whole square of s plus a plus omega square, and this is the ROC of for this expression. So we rearrange this equation. 2 by under root divided by 2 multiplied by 2 by under root 3. We can write this equation like this, and so this equation is in this form. Omega, here omega is under root 3 by 2. This is under square of under root 3 by 2 is omega square, and square of s plus a, here s plus square of s plus half. Means value of a is half and value of omega is under root 3 by 2, and if we take inverse Laplace transform of this, we get 4 by under root 3 exponential minus half t and sine omega. Value of omega is under root 3 by 2. So sine under root 3 by 2 multiplied by t. Similarly, for the second case, for this term, we use standard Laplace transform pair is we use standard Laplace transform pair exponential minus at cos omega t is equal to s plus a square of whole square of s plus a plus omega square, and this is the ROC of this term. Then rearrange the second term as follows. This term is rearranged in like this: s plus a whole square of s plus a plus omega square. So if we take inverse Laplace transform of this term, then we get 2 exponential half minus half t cos under root 3 divided by 2 multiplied by 2. So we get the complete time domain expression. X of t is given by this expression. In previous case, roots are complex. And in this case, when roots are repeated or there are repeated roots, find the inverse Laplace transform of x of s, where x of x is given by s square divided by s minus 1 whole square of s minus half. for a corner time domain signal. Corner time domain signal का meaning क्या है? Means signal is right-handed signal. For repeated poles, x of s is written like this in partial fraction form. A1 divided by s minus 1 plus A2, ये क्या है तुम्हारा repeated pole. So then we write A2 divided by s minus half plus A3 divided by whole square of s minus half whole square. यहाँ पे जो रिपीटेड रूट है इसके लिए जो है तुम्हारा A3 आ गया और इसके पहले भी तुम जो है A2 लोगे और इसको जो है डिवाइड बाई s माइनस हाफ. क्लियर? Then A1 and A2 is calculated as in previous case, but there is different rule for calculation of A2. A2 is calculated by taking derivative as follows. A2 is A2 is d by ds multiplied by s minus half whole square multiplied by x of s at s is equal to half. Then substitute the value of x of s. This term is cancelled by this term and then take the derivative of this and substitute the value of s is equal to half. Here, then simply differentiation of s square minus s minus 1, s square differentiation of this plus 1 by 1 by s minus 1 differentiation of s square. See the differentiation and substitute the value of s is equal to 2. S is equal to 2. Here s is equal to 2. S is equal to s is equal to half. S is equal to half and s is equal to half. Similarly, s is equal to half. And if we simplify this equation, we get the value of A2, which is equal to minus 3. Then A1 is equal to s minus 1 multiplied by x of s when value of s is 1. Then this term is cancelled by this term, and if we substitute the value of s is equal to 1, we get the value of A1. Similarly, value of A3 is minus half. So by putting the value of A1, A2 and A3 in this equation, x of s is given by 4 by s minus 1 minus 3 by s minus half minus half divided by square of s minus 2. Square of s minus half. Then take the Laplace inverse Laplace transform of all these terms. First term, inverse Laplace transform of 1 by s minus 1 is exponential p ut. Similarly, inverse Laplace transform of 1 by s minus half is equal to this exponential half t ut. And for third term, for this term, we use standard Laplace transform pair. This Laplace transform of t raised to the power n multiplied by exponential at is given by n factorial divided by s minus n raised to the power n plus 1. Here value of n is 2, so we get factorial n divided by s minus half 1 plus 1, and we get the value of inverse Laplace transform is t exponential half t. Obtain inverse Laplace transform of this term. X of s is given by 3s minus 1 divided by s square plus 8. Then separate this term and rearrange all these terms. This term is written as 3 cos, this is the value of omega s divided by s square plus omega square. So we can write 3 cos 2 under root 2 multiplied by t, and this is the form of, if we multiply 2 under root 2, multiply and divide, then this is the form in form of sine omega t. So we can write 12 divided by 2 under root 2 sine 2 under root 2 multiplied by t. So we get the value of x of t. Find inverse Laplace transform of this expression. This x of s is written like this, and this is the inverse Laplace transform of this term is cos omega t, and the inverse Laplace transform of this is sin omega t. So we get cos omega t, cos alpha, and this is constant, cos alpha multiplied by cos omega t. Sin alpha is constant and multiplied by sin omega t. So we get the value of x of t. Obtain inverse Laplace transform of x of s, and x of s is given by s plus 3 divided by s cube plus 3s square plus 6s plus 4. So we can write x of s like this, and here this is quadratic term. Either you can calculate the roots of this, then make partial fraction, and then calculate the value of coefficient, then take inverse Laplace transform, or for quadratic term you can write this a for this partial fraction form. X of s is written in partial fraction form a divided by s plus 1, and for this quadratic term you can write bs plus c divided by this quadratic term. Then take LCM, and you can get right hand side expression is like this, and left hand side is, this is left hand side. Right hand side, taking LCM, you get the right hand side expression is like this, and left hand side expression is like this. Then compare the numerators of left hand side and right hand side. Compare the coefficient of s square. S square coefficient a plus b, and there is no coefficient of s square, so a plus b is equal to 0. Then compare the coefficient of s. In this case, 2a plus b plus c, and in right side the s is multiplied by 1. So 2a plus b plus c is equal to 1, and similarly for coefficient of constant, 4a plus c, 4a plus c is equal to 3. And so by solving these three equations, we get the value of a is equal to 2 by 3, b is equal to minus 2 by 3, and c is equal to 1 by 3. So we write x of s is like that. And if we take inverse Laplace transform of this, we get 2 by 3 exponential minus t, 2 by 3 cos under root 3 t exponential minus t, and similarly plus 1 by 3 under root 3 sine under root 3 t multiplied by exponential minus t. Then application of Laplace transform to LTI, linear time invariant system. We know that if we take Laplace transform of differentiation of x of t, we get s x of s minus x of t. This is the initial conditions. Let us solve one example. Solve the differential equation dy by dt plus 2 dy plus is equal to x of t, where x of t is given by exponential minus 2 t multiplied by ut. Assume initial conditions are 0. Means initial conditions are 0 means x of 0 is 0. This is the differential equation, and taking Laplace transform, we get s multiplied in y of s minus y of 0. This is initial condition plus 2y, 2y of s is equal to x of s. Since initial condition is 0, initial conditions are 0, so y of 0 is 0, and we get this expression. Here x of t is equal to exponential minus 2t ut. क्वेश्चन में शायद ये दिया हुआ है एक्सपोनेंशियल माइनस 2t, यहाँ पे जो है एक्सपोनेंशियल माइनस 3t कर दिया. But we know that from standard Laplace transform here, exponential minus at is given by, or Laplace transform of exponential minus at is given by 1 by s plus a. So Laplace transform of exponential minus 3t is given by 1 by s plus 2. So value of x of s is 1 by s of 1 by s plus 3. So we substitute the value of x of s. If we take y of s common, so we get y of s multiplied by s plus 2 is equal to 1 by s plus 3, or y of s is equal to this. Then we write y of s in partial fraction form and calculate the value of a1 and a2. a1 and a2 value of a1 is 1 and value of a2 is minus 1. So y of s is given by like this. And if we take the help of standard Laplace transform here, we can easily calculate the value of y of t, and y of t is given by exponential minus 2t ut minus exponential minus 3t ut. Then these are the application of Laplace transform. Find the steady state response for the following system to unit step excitation. Means input is unit step. Unit step excitation, it means that input is unit step, transfer function is given, and you have to calculate the output of this for this input, means for input signal. This is an LTI system. If response of this input to this, if input to this LTI system is ut and ht is the impulse response of LTI system, then output, how can we get output? Output is equal to h of t convolution u of t. Means yt is given by h of t convolution u of t, and if we take Laplace transform of this, we get, since it is convoluted in time domain, in frequency domain it is multiplied. Means this is the response of, or this so y of s is equal to h of s multiplied by u of s. Means Laplace transform of ut is us, Laplace transform of ht is h of s, and we know that Laplace transform of ut is 1 by s. H of s is given in the in the question. The value of h of s is this. So we get the value of y of s is s plus 1 divided by s multiplied by s square plus 3s plus 2. Y of s is equal to s plus 1 divided by s plus 1, s plus 2. This s plus 1 and s plus 2 is cancelled out, and we get y of s in this form. Then we write this in partial fraction form. Partial fraction form is like this. So calculate the value of a1. You get the value of a1 is half, and similarly value of a2 is minus half. Ys is written in this form, and take the inverse Laplace transform. You get the value of yt is equal to half ut 1 by s ut minus exponential minus 2t ut. And this is the step response of given system. It means that अगर तुम्हें टाइम डोमेन में ये एलटीआई सिस्टम है, टाइम डोमेन में इनपुट यूटी दिया है और ये तुम्हारा एसटीआई इम्पल्स रिस्पॉन्स है टाइम डोमेन, तो वाई ऑफ टी कैसे कैलकुलेट करते हैं? एच ऑफ टी कन्वोल्यूशन यू ऑफ टी. कन्वोल्यूशन करना इजी नहीं होता है, तो यहाँ पे क्या किया तुमने, इसमें यहाँ पे वाई टी निकालने से अच्छा क्या किया, इसका जो है तुमने लाप्लास ट्रांसफॉर्म लिया. since it is this time domain, since in time domain, signal is convoluted in frequency domain, it is multiplied and then put the value of units and hs, take the partial fraction, and you can easily calculate the value of y or t by using Laplace transform. The Laplace transform of LTI system is given by this. Determine the impulse response. Hs is given by this. Then write this in partial fraction form. Calculate the value of A and B coefficients and write Hs of is this. Then take the inverse Laplace transform. You get H of t is that. So by using Laplace transform, you can easily calculate the value of impulse response or step unit step response of a given system, or you can easily solve differential equation. Okay, time is over. Thank you.